Welcome to Physics and History Chronicles, where we explore the wonders of physics, history, and geography from around the world. Today, we're diving into the fascinating world of classical mechanics. Classical mechanics, also known as Newtonian mechanics, is a branch of physics that deals with the motion of objects and the forces acting on them. It was formulated by Sir Isaac Newton in the 17th century and remains a cornerstone of physics to this day. Let's explore the key concepts and principles that form the foundation of classical mechanics. At the heart of classical mechanics are Newton's three laws of motion. Newton's first law, the law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an external force. This means that objects naturally resist changes in their state of motion. Newton's second law, the law of acceleration. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This can be expressed with the equation F equals ma, where F is the force, m is the mass, and a is the acceleration. Newton's third law, the law of action and reaction. For every action, there is an equal and opposite reaction. This means that forces always come in pairs. If you push on an object, it pushes back with an equal force in the opposite direction. Newton's laws of motion are not just theoretical concepts, they have practical applications in our daily lives. For example, driving a car. When you press the gas pedal, the engine generates a force that accelerates the car. When you hit the brakes, a force is applied to decelerate the car. Playing sports. When you kick a soccer ball, your foot applies a force that propels the ball forward. The harder you kick, the greater the acceleration of the ball. Another fundamental concept in classical mechanics is Newton's law of universal gravitation. It states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This can be expressed with the equation F equals g times the product of m1 and m2, divided by r squared, where g is the gravitational constant, m1 and m2 are the masses, and r is the distance between them. Classical mechanics also includes important conservation laws, such as the conservation of momentum and the conservation of energy. These principles state that in a closed system, the total momentum and energy remain constant over time, provided no external forces are acting on the system. Classical mechanics has been instrumental in advancing our understanding of the physical world. From engineering and astronomy to everyday activities, the principles of classical mechanics are all around us. Thank you for watching. If you enjoyed this video, please like, share, and subscribe to Physics and History Chronicles for more fascinating insights into physics, history, and geography. Stay curious and keep exploring.